going to be graphing the function above, but before we can do that, we need to identify a few key details. So before that we do that, let's begin by factoring out our function. And we do that, we are going to get this right here, and we cannot reduce it any further because there are no common factors between our numerator and our denominator. So let's begin by finding our x-intercept, and the x-intercept is the point where the graph intersects with the x-axis. And so that we're just going to set our numerator equal to 0, and with that we get 1 equals 0. So that means we are going to have no x-intercept because 1 equals 0 is not a solvable equation. Now let's find our y-intercept. Y-intercept is the point where the graph intersects with the y-axis, and so that we just simply need to set all of our x values equal to 0, and we do that, we are going to get 1 over 18. So our y-intercept is going to be 0, 1 over 18. Now horizontal asymptote, let's find a horizontal asymptote, and this is the line the graph approaches but never touches, going side to side. And to this we need to look at the degrees of our function. So our first degree of our numerator is going to be 0 because a number's degree is just 0. And our denominator's degree is going to be 2 because this x squared right here. So this is automatically going to make our horizontal asymptote y equals 0 because when the numerator's degree is smaller than the denominator's degree, that is just going to be your horizontal asymptote automatically. Now the vertical asymptote is a line the graph approaches but can never touch, going up and down. And to find this, we need to set our denominator equal to 0, and we do that, we get the solutions of x equals -3, x equals 3. So those are going to be our vertical asymptotes. Now a hole is a break in the graph, and this occurs when there's a common factor between the numerator and the denominator, but since this does not occur in our function, we are going to have no holes. Now, a slant asymptote is a line that the graph approaches but not touch. But instead of the asymptote going vertically or horizontally, it's going to go to slant like that or like that. And a slant asymptote only occurs when the degree of the numerator is 1 more than the degree of the denominator. And since this does not occur in our degrees, we are going to have no slant asymptote. Now, the domain is all possible x inputs. And since we know from our vertical asymptote that we can never touch x equals 3, x equals -3, our domain is going to be x cannot equal 3, x cannot equal -3. Similarly, the range is all possible y inputs, and since we know from our horizontal asymptote that our graph can never touch y equals 0, our range is going to be y cannot equal 0. Now let's look at our graph function. The pink lines are going to represent our asymptotes, and the orange lines are going to represent our graph. And we know a graph occurs here because we have our y-intercept of 0, comma 1 over 18, and we know these two are going to go here and here because two graphs cannot go next to each other, so it cannot go here, here, and here, so they would have to go here and here. And we know they behave this way because the asymptotes, they can approach but never touch, and they go on for infinity on every single graph. So this is our final graph function. Thank you so much for listening.